For this last example in our 2.3 notes, we're going to look at a problem in context. The example says, the height of a kicked soccer ball is modeled by the function h of t equals negative 16t squared plus 40t, where h is measured in feet and t is measured in seconds. Part A is asking us to evaluate h of 2 and use correct units to explain what the value represents. So remember, using function notation, if I give you something like this, h of 2, that means that 2 is the input, so we're going to replace whatever t values we see in our equation with that number 2. So negative 16 times 2 squared plus 40 times 2. If you have your calculator, go ahead and get your calculator out and you can plug that into your calculator. If you type it in exactly as you see it with parentheses and all, you should get the correct answer. You should get 16. We also have to explain what this value represents. So whenever I ask you that question, I want to know what the number you plugged in means and what the number you got out means. Since we plugged in 2 for t is measured in seconds, and we got 16 for our h value, and h is measured in feet. So we would say something like, at 2 seconds, the ball is 16 feet in the air. Part B now is asking at what times is the height of the ball 20 feet. So we take our number 20 and we replace h of t with the number 20. So 20 equals negative 16t squared plus 40t. We're going to practice solving this equation. So since I see 2 variable occurrences, I'm going to set my equation equal to 0 and either try factoring or using the quadratic formula. These numbers are all really big when we're factoring, so it's especially important right now to look for a GCF. I know that I can take a negative 4 out of all of those terms, and it'll just make my numbers a little bit smaller and a little bit more manageable for when I'm actually factoring. I need to be sure that I'm paying attention to my sign since I took a negative number out. And now I can go through and see if I can find 2 numbers that work when factoring. So I'm going to ignore this GCF of negative 4, and I'm going to ask myself, are there 2 numbers that multiply to give me 20t squared and add to give me negative 10t? I cannot think of 2 numbers that work, so at this point we are going to use quadratic formula. So x equals opposite of b, so positive 10, plus or minus the square root of 10 squared, minus 4 times a, which is 4, times c, which is 5, all over 2 times a, which is 4. I'll go through and simplify this. 10 plus or minus the square root of 10 squared is 100. 4 times 5 is 80. And 2 times 4 is 8. Then I'll get 10 plus or minus the square root of 20 all over 8. Typically in a problem like this, I would ask you to simplify this radical, but since it's a problem in context and I'm asking for a time, I do actually want the decimal answer and not just the simplified radical. So at this point, you're going to type this into your calculator one piece at a time. So first you're going to type in 10 plus the square root of 20, and then divide that by 8. Then you'll do the same thing and type in 10 minus the square root of 20 and divide that by 8 again. So go ahead and pause your video and do that. When I plugged both of those things into my calculator, I got 1.809 and 0.691. Those are both seconds. So we remember we were answering the question, at what times was the ball 20 feet above the ground? And since a ball both goes up and comes back down, we're going to hit 2 different places. If you wanted to check your work, you could type your quadratic equation into y1 and your linear equation y equals 20 into y2 on your graphing calculator to make sure you do get those 2 points of intersection. The last part of this problem in context is asking about average rate of change, and we want to know the average rate at which the height of the ball changes on the interval from 0 to 2, and explain what it means. So remember, with average rate of change, you're always thinking of your slope formula, y2 minus y1 over x2 minus x1. I'm always going to give you your x values, so 2 minus 0. And then we take these numbers, 2 and 0, and plug them into our equation to find the corresponding y values. Well, I already plugged in the number 2 up here in part A, and I got 16. If I plug in the number 0, these two terms are both going to turn into 0, and 0 plus 0 is still 0. When I actually work this out, 16 minus 0 is 16, 2 minus 0 is 2, and 16 over 2 is 8. So there are two ways that you can describe this. One way is like, okay, I know that they understand like the basic gist of average rate of change. And the other way to describe this, if I see this on a paper or an assignment, I'm going to be like, wow, they really understand average rate of change. So the simpler way is just to say that the average rate of change is 8 feet per second. That's how fast the ball is going. If you wanted to be more precise and really show me that you understand average rate of change, you would write a sentence kind of like this. You would say, on average, between 0 and 2 seconds, the ball increases at a rate of 8 feet per second. The reason that's a little bit more specific is because this 8 feet per second only holds true between the times 0 and 2. It doesn't hold true for every interval that you're looking on this curve of the ball going up into the air and coming back down.